I want to dive into some of these pictures that you sent us, and we're gonna talk about some of them. They're in a random order. Just let me know if you can see them. So
All right,
this
so
is
we talk about proper startups.
Yep.
This was started up by a contractor who did CO2 work, but he neglected to say the only two CO2 work he did was two cascade systems. So he started this system up by himself, and they were having all kinds of problems. We went out and looked at it. This is the first and only for me on a CO2 rack to see the heads baked on this compressor.
That's hot.
If you look down, the tag used to be silver. So what happened is the contractor did all this. Besides all the other verifications he didn't do, he didn't check his dip switches, and his high gas dump was dumping into the rack all July and August.
Ooh,
when we were running anywhere from 12 to 1300 psi because this was an air-cooled rack. It was bad enough that it actually changed the color of our taps that were going to the discharge line, and on the Guttner condenser, the yellow tags that are always yellow were baked yellow just like that one, or brown. So yeah, this system got hot.
Yeah, and you got to remember when this happens here, that oil inside there works at a certain temperature. So now all that oil is getting broke down. It's passing the oil separator, maybe getting logged in the system. That oil is going to have to, for sure, they need to change not only the compressor, that oil would have to be changed in this system. I don't know if they did or not, but.
Oh yeah, we went back and we visited this site because of this. I went back a third time. We broke the compressor down. We pulled the heads apart. Do you have the pictures with the heads? These were the heads. This is after the first visit to pull the compressor apart. This is after it disintegrated. But before that, it was just they had baked the oil on the discharge valves. They were glazed like a purplish color from the temperature. You see how the oil is baked on it. This rack's only been running 5 months.
Wow. Yeah.
So when we put it together the first time and restarted it, I said, well, minimum, you're going to have to put new heads and bolts on here. But then when we started the compressor back up, we got a bird chirp in the bearings. I says, well, now you're going to have to replace that compressor because now the bearings are gone. And yes, that oil, once you start heating it up, it starts breaking down. Show one of the piston cylinders. Yeah, you can see how that go back one. That's how hot it got. It changed the color. It actually tempered the valves and changed their rigidity. I go to the cylinder.
And there's one check to check this. There's one check that you can do, and this is the most important check that most people on compressors don't do, is your discharge line temperature check.
Yep. So I was really surprised not to see any baking. Usually you'll get a yellow glaze once you start baking that oil, and then it ruins your honing, and you're not able to retain your lubricity for your cylinder. So usually you'll get striations in the cylinder, but I guess it was too short of a time, but the cylinders still look good. That's why originally I was good to go with just replacing the heads until we started it back up.
Yeah, so there's a few more. That right there.
Yeah, they're actually those are your honing marks, those cross X marks.
But right here,
they're a little exaggerated there, but that's honing.
This looks like copper plating to me right here.
Yeah, you can start to see a little bit of it, but I think it was more a light issue.
Okay.
From the light.
Now, why would you take one of these shots, Paul?
These are, if you think you've got a discharge valve plate problem, take a thermal picture of this compressor. This is a good operating compressor. I took this because Trevor was looking for some pictures, so I took some nice thermal pictures for him to show him some operation. You can see the path. The compressor on the left isn't running. That's the number 2. This is the number 1, and you see the path of the gas from down to the bullhead to the right to the discharge separator. And you notice it's not heated up on the left side because the number 2 compressor is not calling.
Now, this is important. These are new tools that I really wish I had when I was in the field.
Yeah, no
and you can do startup. This will help you with startup. This will help you with maintenance really quickly. Here's another beautiful shot of a 3-way valve, it looks like.
Yeah, you can see the path of operation. It's coming down from the separator up and turns left, and then comes out the bottom, the normal path of flow to the condenser. If it was to go straight, it would have been to bypass the gas cooler.
Yeah. And like these are such great images. And here's another one of oil separator and oil reservoir.
Oil separator, oil reservoir.
Like this is so quick, and you can tell so much from your system using something like this.
Yes, sir. That's good. Yeah, that's still from that very first compressor. All right, so this picture's in here. This is my charging station. This is the one I carry for guys who try to use a regulator to charge CO2 because it ain't going to work.
Yep.
Because you're going to create a pressure drop and you're just going to end up icing up the regulator. So what I did was I took a couple of valves that are actually shipped with the racks and put the male to quarter-inch tap adapters on it. I ordered a gauge, and then I ordered the GA320 connector, the brass connector from Amazon, and bought a T and created my own charging station. So what I have here is straight through is for charging. So the bottom would be closed and the right one would be open. But when I get down and my bottle hits 500 pounds, and that's why I have a gauge on there, because my vessel's 500, I can't charge past 500. There's no differential. So then you can isolate the right, use the bottom one to bleed off the pressure in between there, change it, put a new one on, use the bottom to vent it out, and then start it up again and just keep right on going.
Yeah. No, that's a great idea. And once again, this stuff is easy to find. You can use these. The big thing is make sure you get the gaskets for these. So if you're at the suppliers getting CO2, get the gaskets for the CGA 320.
All right, so this contractor did a nice job with standard refrigeration piping practices. This is actually the riser to the roof, and you'll notice how he turns. He came off the bullhead for one of his suctions. His other suction comes over and drops down. And I've had contractors literally pipe off the top of the suction line to return back to the rack, and then you're just killing your oil return. And for people out there that don't know, there is a formula for a P-trap. If you don't buy the pre-manufactured pre-taps, there's a formula for the pipe size and the depth of the trap. You can find it online almost anywhere.
Awesome. And so that's why you take this one out, because I'm used to when I'm doing, like when I installed a ton of stores, HFC stores, when I'm going from the cases, we'd have a trap down at the case, and then we'd go all the way up, just say it's 20 feet. We'd put an inverted trap 20 feet up on top. This one here is going along. This is not going up. This is just going along, and you're pulling off that one. That's why it drops down. So any oil goes down into this trap. Is that correct?
That's correct. This is the main return coming back. Well, I'm glad you mentioned the case piping, especially with CO2. CO2 goes from a huge mass flow to a very low mass flow in a quick time, because once it reaches temperature, it's just going to choke off. The control valve is just going to start cycling 5, 10, 15%. When we do that, we're losing our mass flow. Highly recommend your normal traps top and your inverted trap at the top and your regular trap at the bottom. I would use a mid-rise trap on anything over 18 feet.
Oh, good. Yeah. Anything over 18 feet.
Yep. And then all your piping going back to your risers need to be pitched that way for your suctions. Yeah.
Or 3 or 4 meters for.
This is stuff we've been doing for 40 or 50 years in the industry.
Yeah, it hasn't changed. It's no different. You need to get that oil back. It's make sure those lines are sloped back to the compressor rack house, right?
Yep. We have another one here. I don't know that we can see on this picture.
Let me go back.
Go back. We come off the side of our CO2 lines. The reason we do that, because we discovered way back before I even started here, that if you start to get low on CO2 and you come off of the bottom of the line, the first 2 circuits will eat everything. So we come off the side, and that way we stand a better chance of everybody getting a little bit of liquid to keep the systems cool.
Okay, so because I talked to lots of different people, most manufacturers don't do it that way, but I know I've seen it in your documentation that you guys do it that way.
Yeah, we learned from experience back in the day. I think we've been doing it a little longer than the other manufacturers.
Yeah, I think a lot of them still do it off the bottom, not off the side, like you mentioned.
If there's no other option, coming off the bottom is not going to kill you.
Exactly. So another shot here.
All right, so CO2. 2 or 3 years ago, there was a shortage of CO2. The Alabama plant went down for maintenance. The Mississippi plant at the same time came up with acetone in their water, and couldn't produce CO2 until they came up with a solution. So we did come out with a document that if all else fails, standard CO2, but you would need to run through a filter dryer. You would have to do non-condensable checks in both your vessel and your condenser, because your condenser is not the only thing, especially if they're on the same plane, like we do on our standard racks on I-beams. If they're on the same plane, if you've got air in your condenser, it's more likely going to end up in your receiver too. So if you got it there, vent it in both places. But you're going to have to do a non-condensable test. But we highly recommend CO2 grade, Coleman grade, refrigerant grade, instrument grade. Those are your options right now.
Yeah. But the other manufacturers do bone dry too. So I know you guys recommend Coleman grade and refrigerant grade or grade N4.0. Then I know Bitzer says 4.5 in their manuals, and some other people say bone dry, which is N2.5. What you need to make sure is that you need to get your customer up and running. And like Paul said, if you need to get bone dry, you use that, put it through a filter, change the filters, do non-condensable tests. You need to get up and running. Because there's another thing I seen in your manual where it says don't want to use Dewar tanks because they're lower pressure. You know what I mean? They're 300
Yeah.
inside and they're cool. But if you need refrigerant for your customer, and I know manufacturers are contractors who use Dewar tanks on larger systems, that's what they start with, a bunch of Dewar tanks. You need to get your customer up and running. Yep. So it doesn't matter if it's Dewar tanks or if it's lower quality refrigerant. The problem is when you start going too low of the quality of CO2, and I did so much investigating on this, is that you can get other non-condensables in there. So not moisture, but you can have some oxygen, you can have nitrogen.
Yes.
That's the problem when you start to go with lower and lower quality CO2.
And always be careful, especially if you're starting your first new CO2 rack and your local distributor doesn't usually carry CO2. Make sure you're not getting helium capped tanks.
Yeah, exactly.
All right. So maintenance. This is actually a BAC condenser unit with the pads on the side. These pads are what I would like to call non-functional. They've probably been out of service for a couple of years. You're beyond the ability for the cellulose to absorb the moisture and help to evaporate as it passes through. Maintenance, guys. These CO2 racks, just like any rack, you got to do the maintenance. If you submit maintenance invoices to your customer and they neglect them or reject them, stay at them, because this is going to be an issue.
Yeah.
And this was one of the first Danfoss stores stuck in a Kroger with the BAC control, with the BAC rack, and this is what it looked like. How much work do you think you're getting out of that condenser in the summertime?
Yeah, no, and it's all about the same thing. Most of the systems would run out there way better. HFC, CO2 doesn't matter if the maintenance were done. And then I hear people excuses going everywhere. Oh, look, it's the customer who don't want to do it. Oh, it's the contractor who don't do it properly. Yeah. And at the end of the day, it doesn't matter. You're just going to get it done properly. Do it right.
Yep. All right. So this is Guttner. For anybody who's not familiar with Guttner, this condenser does not have a pump system in it. What it has is a water meter and a modulating valve. So if you'll see right here up on the top right corner, put your right up there, that little white box near the control panel. Yeah, that one there. That's the temperature humidity probe that the controller uses to determine the humidity and ambient temp sensor. And then on the middle side, on the left of the control panel, down here, put it in the middle, over here on the pads, you're going to have a temp sensor in there. You'll actually have two temp sensors in there, the one from the controller for the Guttner controller and our pad temp sensor. Because if we're going to if we have an adiabatic condenser, we use on all of condensers, we use a 10-degree approach. So that means there's going to be a difference of 10 degrees between the air entering and our liquid line.
Okay, so let's just get this straight. So on these ones, you'll have a pre-filter and a post-filter. So this would be the pre, so the outdoor ambient humidity, and then you'd have one behind the pad. Is that correct?
Yep. And measuring. What it does is when we reach 2 parameters, we set our controls in here. We'll modify the programming for an 80% fan and 75 degrees. Some areas, if it's a little warmer, we might go to 73, but basically 75 degrees. So you have to have two things at one point to make the fan want to go to pre-cool, it's called. So on a Goodner, 80% fans and 75 degrees, we're going to go pre-cool. So what's going to happen is this fan's going to go into a 4-minute, what they call wetting period. And this rack is just going to run wide open with water. You'll see a stream of water coming out the drain, probably an inch or better thick. And what that's doing is it's saturating the cellulose to get it nice and wet. And then after that pre-wet program ends, then you're going to go into the control mode. And then what it's going to do is what you see right here, using the probe that's in between the pads and before the condenser, and whatever the specification, whatever the algorithm's calling for, it's going to wet and dry. You can see it's just wetting it a little and drying up. And that pad will do that. You'll watch it dry up, and then you'll watch it wet again. And at that time, it's just piddling out a little bit of water at the time it's operating.
Okay. And
all
so
right.
Why this is important is now we're reducing the amount of flash gas going into that receiver. So we're keeping it below the critical point. And you're saying,
well, you'll actually see the condenser discharge pressure run anywhere between 1050 and 1150 at 95 degree ambient versus 1300. And a lot of our customers like Wegmans and such are actually starting to put these adiabatic on their standard HFC systems.
Yeah.
But why not?
Well, it works, and it all depends on where it's at. You know what I mean? Like some places they're going to be more effective and more efficient than other places, depending if it's super humid all the time, or it's not. It's a really cold place and it's always cold, and you just stay in subcritical. But okay, so this is cool. This is important to understand, because now you not only have the high pressure valve and the flash gas bypass valve, but now you have water for adiabatic. You get the fan staging up and down. When you hit a certain percentage of the fans, you hit the certain temperature and relative humidity. That's when it activates it's just a solenoid that opens up and starts to feed.
It's actually a modulating valve, and it meters the flow.
Okay.
It's like it's a Belimo valve.
Okay. And does that measure the gallons per minute, or just?
They do. They actually measure the water flow using the water meter in line with the Belimo.
Awesome. That's perfect.
So a couple other options that Goodner has is you can set it up to what they call an LCCM feature. And what that'll do is, as the fans are ramping down when it's get a cooler ambient, instead of them ramping down to 0, it'll actually start stepping fans off. So when you hit 0.9 volts, the number 3 fan, unfortunately, the number 3 fan is the one on the header end, because they number their fans from the control panel to the end of the header. But you will start dropping out the number 3 fan, then the number 2 fan, and the number 1 will run all the way to 0. And then when it restages back up, it does it the same way. And then in the winter, when you're minus 20 out, you stand the chance of steaming any moisture that might be on that coil, because the fans aren't running, and that moisture likes to waft up to the volutes and the fan blades and freeze there, and then freeze the fans in place. And we had this happen a lot. That caused a lot of alarms, and we did a couple other things to take care of those. But on the Goodner, if it goes to start and it doesn't sense movement, it senses high amperage, it'll jitter the fan back and forth to try to break it loose.
Okay.
So
is that a setting you turn on and off?
No, that setting's built into the algorithm.
Built in. For these systems that do you recommend leaving the pads in all winter? Do you recommend them taking them out? What is that? Just leave them in?
My recommendations are, you can leave them in during the winter. You need to service them every year. You can't let them get like the other pads.
Yeah.
You can clean these, get a couple years out of them. If they get really bad, flop them around. You can get some extra time out of them while you order some. But I would recommend having a set of pads in standby. When you buy the rack, buy a set of pads. Keep them in standby. That way they're there.
What do you recommend cleaning them? What's the best way? Just hose and water?
In the spring, prior to use. Before temperatures are going to start reaching 65 degrees, I would go out and do maintenance.
And then the maintenance for them is taking them out and washing them with a hose water, not pressure washer for sure.
Not a pressure wash, because this is cellulose. It'll bend real quick, and it will get brittle as it wets and dries out also. So you got to be careful when you're washing out. Do backwash on it and clean them out and put them back in. And these are easily, go back. These are easy. You just take off. There's on the top panel up there. There's two. There's one on the top, one on the bottom. In the middle, you take those off, and that whole panel will just lift right up and come off. And then these bars on the outsides, you loosen them up and they flip out and allow the panels to drop out. You take your directional panel out, then you can pull the bottom ones out. Remember the order you take them out and put them back in.
Yeah. That's very important.
Yep. All right, so what we have here is a valve that is obviously having an issue. Is that a Danfoss? I can't see. It looks like a Sporlan. So the Sporlan, I haven't had one of them apart, but I'm almost guessing there's probably a strainer in here. On a Danfoss, you'll have to take the top of the valve off, and there'll be a conical strainer inside. And I would look at something in there is clogged up.
Yeah, something you want to check. And this is important. This is a valve, not a manufacturer, not a Hill issue. This is a valve. What's going on? Why is it plugged up? Is it dirty? Have you been using purging with nitrogen when you put this door in? You got to
exactly. All right, so this is actually a Sprouts job.
Oh, looks like a nice system.
This is what we'll call a 3x2 rack. You'll see the 3 green Bitzer compressors over there. Sorry, Justin. And then you'll see the 2 digital scroll and a standard scroll. Yep. Yay, Cooper. Got to make everybody happy. And over to the, hold on, go back.
Yep.
Over to the left, you'll see the receiver. Up in the very top left is one of our iCAD controllers. That's a 0 to 10 volt. Oh, yep, that's it right there. And then our stepper bypass. That's more than likely a CCM 30. No, that rack probably is CCM 40. That's a stepper valve, 4 wires.
Yep. And then you see the controller right here for it.
Yep. I'll go up to the right up there and go to the 326A. So this was being controlled by a 326A, not by an iPro. If you have gas bypass valve issues, and most of the time this valve wants to go to the closed position, if you start having issues with it, on the bottom right is wires 21, 22, 23, and 24. It's going to be white, black, red, and green. Those are your stepper valve control wires. White and black, one set, red and green are the other. Check your voltage there. Your voltage is going to be anywhere from 3 to 5 volts. If it's 3 to 5 volts on the left, it needs to be 3 to 5 volts on the right. If they're not, the 326A operates off a holding value. It constantly has voltage on the gas bypass valve. So if you lose voltage on one side, it's going to always creep to that direction, because now they're not both 5 volts. One's 5, one's 4.5. It's going to start creeping to the closed side. So if those values are not correct, you got a problem with your 326A. But if they are correct, go over and check your AKC filter on the left. Coming out of the bottom, they should be the exact same. I don't care if you got 5 volts going in and 3 volts coming out. They both need to be 3. Yeah, good way to check and verify if you're having problems with your gas bypass.
And that's easy. You take your meter, and it's already, and you just check it. Put on DC volts, check it, and you can see.
White black, you're going to have 5 volts. If you go white black on your red, if you just take them over and drop them again on the red and green, it's going to be negative, because you need to reverse your leads. All right.
Could you ever the issue? Have you seen it where the wires are loose, so someone just didn't tighten them down and change the voltage up?
Oh yeah, we have had the wires loose. The diodes that are in the filter like to fail.
Yep. But if you take the wires off and you go, just say you take the wires off and you go to the 326 and it says 5 volts on one, and you go to the 326 and it says 3, then there's a problem with the controller, correct?
That's correct. Now, if you do have an issue with your filter, just pull the wires off the bottom of the filter and just connect them directly to the bottom of the 326A. Order a new filter.
Yeah, because it could be the filter. Because you want to make sure that you're not replacing components. I've seen it and heard it before where they're changing a valve and it's a transducer that's the issue, not the valve. Things like that.
Well, on our oil system, it's like that because Did I send you any pictures of the oil system of the HPSO 1 or 2 sensors?
No, but we've talked about it before.
Yeah, the how it works is we've got a sensor that sits horizontally in our receiver, our separator, and our vessel. They work off conductivity. So there's a isolated probe in the center of the well. There's a well, and then there's a power head. That well is isolated on the inside so that you're going to have your positive and your ground is the outside. So your fluid is your actual switch. So we use Bitzer 85K, BSE 85K. Those switches are calibrated to that Bitzer oil. So if you start using another oil, you're going to start changing the capacity, the conductance capacity of your oil and changing your switching points, as well as using a non-approved oil. There we go. Yes. And you'll see that right on the end there, it is that red ring. That's a plastic isolation for the center rod. So what it is you can remove the power head by taking out the 3 2.5 millimeter Allen screws. And the end of that head is going to have a little conical device that is on a spring and goes down and meets the probe in the center. So flashing green is you have a heartbeat. And they did it without and never even said anything. All of a sudden we had these probes showing up. We're having a green flashing light from HP sensors, which was a great thing because now we had a heartbeat. We knew we had power. In the old days, it was just set there black. And the only way to know if you had power was to actually put a meter on it.
Yep.
So now we got a green flashing light. It turns to red in the separator. That means that we now have fluid going through these holes and making capacitance and making our switch. You have 3 wires. You got a number 1, which is your 24 volt in. You have a number 2, which is your common. And a number 3 is your switch leg that come out of that power head at the top. So if your lights are red, we now have.
Yeah, if your lights are red.
If our lights are red, that means we now have fluid present, and we have switched our to our active circuit, which now tells one of our cube relays for the separator is going to be the OSLAR relay. That relay takes 24 volt DC to energize the relay to make a 0 to 5 volt input for our control circuit for our control system. So if the relay's red, the cube relay needs to be green and energized. Follow the path. Now, if the light's red and the cube relay is not energized, then you got an issue with the switch. Investigate it. Pull the head off. Just don't order a new switch. Pull the head off. It could be the wires were loose and now they've come loose.
Yeah. So important. Just little tips like this.
Test it first. And then our cube relay makes an input to the input screen, and then on an Emerson, that'll be a flex combiner. Look at the flex combiner. It'll say high oil separator will be on and tell the system to work. So follow it through the whole cycle. Don't just, hey, I'm not feeding oil. Let's replace the HPSO2 sensor 3 times before we call somebody.
Yeah, exactly.
All right, so this would be, I'm almost guessing a BAC by the piping, but this is a drop leg into a bullhead, which is good. But problem is they've landed the drop leg temp sensors down here on the common. You will never work like that. If you have liquid all the time, you'll be okay. But if the rack ever goes transcritical, the temperature difference between the 6 to 8 inches leaving 6 to 12 inches header leaving the rack to there is going to be significant enough. It's going to affect the algorithm, and you're going to run off on high pressure. It's going to think, it actually makes it think there's not condensables in there.
Okay. So where should this be located then?
That should be located. Now, pick a side. If it's 2 drop leg, pick the left or the right. Me, I like to use, if it's a BAC, I'll use the left side because that's where you'll see that sensor, that wire going up to the middle of the condenser on the right. Nope, go up to the right over there. There you go. Nope, back over there.
Yeah.
Next to the tag, you see that blue and white tag? That's our pad temp sensor.
Oh, right over here.
Right there to the left, that little gray box, 4x4.
Yeah.
That's your pad temp sensor.
Okay.
So I would like to have my drop leg control on the same side. If it's a good nerve, it's going to be in the opposite side. So I'd like to use the right side, but
Okay.
always within 6 to 8 inches of the header on a flat piece of copper, if possible, insulated 6 inches to either side with 1.5 Rubitex with a PVC wrap. And the reason I say PVC wrap, we want to keep the insulation from getting wet, because if it gets wet, it's useless.
Mhm.
3/4 of that sensor is in contact with the Rubitex, and only one is in contact with the pipe. So if the Rubitex gets wet, it's going to affect the sensor more than the pipe.
Mm.
The white will also keep it from the rain from getting to it and the heat from affecting it as much. And most of the jobs that I go on, the older jobs that are having problems, first thing I check is where this is landed and how it's insulated. On jobs that were running for 5 years, had problems for 5 years, I go out and I look at them. We relocate it, we put it in a proper place, we insulate it, and the job, all of a sudden, the rack just starts working. It just gets, it goes, "Buh."
Yeah, it's like, oh, 5 years of this.
Yeah.
So, okay, just to be clear, so everyone knows, so right here would be your pad sensor in behind the pad.
That's correct.
So, and then right down here, you would say right around here, 4 inches out of this line, you would insulate the outlet drop leg sensor.
Put it mounted at 5 and 7 o'clock.
Yep.
Because the reason we don't mount it on the bottom is there might be oil in the pipe, and that's going to insulate the sensor.
What a coincidence. That's the same as we do in regular HFC systems on
No
your
kidding.
DXC bulbs. Imagine. Imagine.
All right, so contractor did a pretty good job here, other than he did bullhead, because whenever you're feeding a condenser or an evaporators, if you have 3 evaporators, you want to feed each one of them equally with the same amount of suction pressure return. Here they did the same thing, but they neglected to put a high vent up there. So if you get non-condensables in that gas core, how are you going to vent it? You're going to drill a hole in the top?
Yeah. So what's the best, this is good. I get this question all the time. What is the best way to do that, to test for non-condensables and then get rid of the non-condensables? Just say someone puts some non-condensables.
Well, what first thing you want to do is you're going to pump down your system, then you're going to isolate your liquid and your supply and your hot gas vapor to your hot gas vapor and your liquid return. And you're going to wait about 15 minutes, let it settle. And then you're going to take an ambient temperature and a pressure reading. They should correlate. If your ambient says the pressure should be 900, but your pressure is only 850, then more likely you got non-condensables in there. But they're not going to match. There should be a PTR relation as long as there's liquid and an ambient temp.
Yep. And so you do that right up around here, wherever that access fitting is, correct?
Yep.
Do you recommend running the fans for 15 minutes or not, or does it matter?
It doesn't matter. You can run it to help keep it cool, because it's going to be ambient air going through it.
Yep.
So the fans running should not make any effect on it.
Okay, so you check it and it say it's 50 psi off. It should be 900, it's 850. You just, for CO2, you just open the vent and you bleed off.
I would blow it down to about 500 psi, because my guess is it's going to be upwards of 900 to 1,000 when it's sitting there idle, depending on the ambient. So yeah, I would blow it down to about 500 psi. Then I would in the vessel, I would probably blow it for about 3 or 4 minutes.
Yep. And then do this test again.
Start it back up, let it run again, and do another test.
So do you let it run for a while? Like, do you run it for 20 minutes system?
I would let it run for an hour.
An hour. Yeah. And then do this test again, and you do it until you get all the non-condensables out. And then if you add after that, then you would add extra refrigerant if you needed to.
Yeah, that's correct. And you probably would, because you just blew off a pretty good amount of vapor pressure.
Yeah, exactly. Excellent. And this is for CO2. You don't do it this way. You don't blow it off for HFC. You got to recover that gas off the top.
Yep.
Just don't blow that out into the atmosphere, guys.
You recover it to an empty bottle.
Yep, exactly.
As you can see here to the left, this is factory piped, and we have a high vent.
Right up here.
Yep. And we actually send 2 of those with each job.
High vents?
Hey, just a spare vent.
Okay.
Spare ball valves, high lock ball valves.
Yep. And so this here would go down to the header of your reliefs, and this is where it comes out here.
This is our actual hot gas applied to the to the condenser.
Okay.
That looks like.
That's this one here.
Yep.
Right. This is your hot gas into your condenser. And then this pipe here, what's this front pipe? This here is your
That's
vent.
probably the contractor's vent line.
Okay, vent line. Perfect.
All right, so we're using the Emerson OMC oil controls, and we're using Crewan oil control modules. Yep. Both of them operate fairly the same. This is a sensor, the other one will be an optical. And what you'll have is your power light will be green.
Yep.
If you call for a fill, your center light will turn yellow.
Yep.
And it'll stay yellow for 2 minutes. If you don't fill in that required 2 minutes, you're going to get an alarm and you'll see a red light come on the alarm section. But you get a call, you had an oil loss, you get out there, the compressor's running. The reason is that this sensor will actually try 5 times to fill before it locks out. So it could have taken anywhere from 2 to 3 times or 5 times to fill, but it did fill. You need to look at it. Things you need to look at. We've got a inline 8mm bullet filter in the liquid line, oil line from the separator to the reservoir, from the reservoir to the compressors, to the actual header for the compressors. Take them apart. Don't be afraid to take them apart. Do the due diligence. Figure out why. If they're clean, if they're dirty, you can take them apart and you can clean them. It looks like a little porous rock when you take it apart, about the size of a thimble.
Yeah. And just got to isolate the stuff properly, make sure there's no pressure in there, and then you take it apart, take a look. This is our job. This is why we're mechanics, and this is just a small piece of what we need to do. A quick question on, I think, the last slide on the drain leg refrigerant piping. Is it preferred to pipe on a run and not bullhead the drain leg together? I do understand the increase in the pipe size. So do you prefer to bullhead or not on the drain leg? So when we
bullhead on the drain leg.
Right here?
Yep.
Always evenly piped. You know what I mean? You want to make sure it's always symmetrical.
If you ran that pipe to the right side to that 90 and had a longer run, even though it is a short distance, there is a difference there.
Yep.
All right, back one more.
Back.
Hit oil. The other thing you need to look at if you're not transferring oil to your medium temp compressors is what is your vessel pressure, graph your vessel pressure, graph your suction pressure. You need a minimum of 65 PSI to push oil on a differential through that solenoid. Some people say minimum, they want to see 80. I want to see 100 because there's too many times where the suction and the vessel will modulate to each other. And if they sit there too much and you call for oil, you're not going to transfer.
Yeah.
Or you're going to transfer slow. So look at that also.
Yeah, I have so many people in my training. Well, what is the exact number that it needs to be? Well, it depends. And it all depends. It could be 70, it could be 120, but you need a differential. When you start to get below 60, when you start getting below 60, you're going to start running into issues because it's just not enough to move that oil from your reservoir into your compressors, because that pressure could change a bit and then you might run into issues. So yeah, if you get 70, 80, 90, 100, depending on the system, it could be 120 PSI differential. So 5 or 6 bar, but there needs to be a differential. Your flash tank cannot, or your receiver cannot run at the same pressure as your medium temp suction. No different in your oil. Your oil needs to move. That's a good one.
We've had some commissioning companies come in and tell the contractors, hey, this is a plus 25 degree rack. You need to raise the suction pressure to 440. They do that within a week to 3 weeks. They're tripping on oil.
440. That's high. I haven't heard somebody running them that high.
No, we run 400.
You run 400. I see that some people at 420 have heard, and 410, but I never heard 440. Like that's.
Yep.
That just means you got to raise up. You would have to raise up the receiver pressure, and then that's risking the temperature of your product now, right? So.
It is, and then also you got to be very careful raising that receiver pressure from 515. I've seen it up to 580. Well, 580. How far are you from the 652 relief valve?
Yeah, there are those.
What you're doing, A lot of Advancer put a lot of work. They've been doing this for multiple years, 20 plus years. CO2, they put a lot of work into these set points. And there's a reasoning why. And contractors going out and inadvertently just changing settings to try to overcompensate for another problem is not the answer.
Yeah, 100%. Totally agree. And that is your settings too, right? So this is
That's
where when
correct.
you're working on Hillphoenix Advancer, when you're working on somebody else, they could be running at 600 because it's a different design. They could be running air conditioning in that flash tank, right? So
Yep.
just remember, you got to understand the system you're working at hand, and no different for the other manufacturers. Don't just go and start changing the settings. There is a little minor tweaks, but that's what you work with the manufacturer on, because this is what the customer designed, with hopefully the manufacturer as well as the contractor involved. And that's where I think that's where the best equipment is getting built, is when the manufacturer, the end user, and the contractor all work together and understand where it all is. And this is where set points don't start getting changed, because that leads into massive issues. And I've seen it time and time again. People calling me up. I don't work for a manufacturer either, but what's going on with this? What did you change? I played around with this a bit because somebody told me that I should try this and the PIDs. I'm like, don't touch that.
Well, we had one of the customers control company that does their programming limit the high pressure valve to 80%.
Oh, wow.
Why would you do that? Here's the deal. We sized that valve for 80%. So you just limited the valve to max capacity with no room for extra measures. We want that valve to keep breathing. As long as that valve's not at 100%, then the system is still working. We're trying to keep, when you're transcritical, supercritical, we're trying to keep that valve on the wet side, top side of the dome, where we're producing 80% of the liquid vapor dropping back into a liquid. We got a severe thunderstorm and that just passed that high pressure valve. Yep. And people start adjusting them fittings, then those settings, they start changing where that algorithm's working. And the next thing you know, like they came back to us, they had 2 racks. They said the compressors were undersized. Well, I pulled the programs, I corrected the issues with the iPro programming, had them put the valve back to 100%, because what they were doing is they were producing probably 50 to 60% liquid, and the rest was all gas that had to be consumed by the compressors. And then all of a sudden you're dumping more gas than needs to be dumped, and you become inefficient.
And this is very, very important, because maybe the design was a mistake. Not saying it, because it does happen, and maybe you do have to limit it, but most of the time that the valve is sized by for that specific system by the manufacturer. So changing settings like that can really cause a massive amount of issues.
And if you think you have a design issue, contact us. We'll go through it. We'll look at it. But not saying we haven't made some mistakes, but we've got about 1,100 of these systems in the U.S.
Awesome. That's amazing. 1,100. Just growing fast. Okay, next picture.
Yeah, this was one of our older liquid line valves. We don't know why the contractor was taking it apart here, but we left it in there. Here's an issue. Say you got to shut that system down in an emergency. How are we closing that valve?
Exactly. You got to leave that
While
on there.
we're on that valve, back from 2016 all the way through 2019, we finally got a call back from Mueller. We were using the Mueller ball valves on our isolation valves for our condensers, heat reclaim. There was a problem where some of the valves wouldn't hold. So I'm going to get this out here on a national level with this podcast. The ball valve is shaped so that it has a pass-through, and then as it closes, there's a bleed port on the downside of the pressure, the lower side of the high pressure side. Well, Mueller actually had where the valves are inserted 180 degrees. So the vent was actually on the high pressure side. And the symptoms were you were trying to blow down the separator so that you could change the separator. You would hit about 400 PSI and then something would let loose and you could never stop it from leaking by. We have a bulletin that's out. Basically, you got to determine which it is, if it's the heat reclaim inlet outlet or the condenser outlet inlet. Determine which one it is. You can remove the lock that goes, the little bead lock in there, you just punch it out
Mhm.
and you rotate the valve 180 degrees, put the lock back in, and that'll 99% of the time take care of your blow-by problem.
Excellent. And so where would I find this bulletin? This is good.
Dude, that's something on the Hillphoenix website.
Okay, I'm gonna look it up and find it.
So
Excellent. I'll add it to the podcast for anyone who's on there so they can take a look at that, because this is important. This
yes,
stuff right there, that stuff, most people won't know that unless you just said it. You know what I mean? Because it's buried away on a website and you guys promote as much as you can, but it only goes so far, right? So gotta get into
yep.
these bulletins. All
We're
manufacturers
working
have
on better
bulletins.
ways to distribute the bulletins. This is kind of hard because we're not in contact with every contractor in the country. It's better that we get to the customers, let the customers distribute them.
Yeah.
On our new racks, this is an old Flex 1.0 rack. This is actually Wentzville, Missouri, where we did a change out from another manufacturer's rack. See these posts here? Okay, this is Wentzville, Missouri. The Midwest, even any state, the issue you have is when you have an adiabatic, you have a V coil or you have a square BAC. Well, the air can influence these things greatly, especially in the wintertime. We can put all the control we want in to try to keep the head pressure modulated, but if the wind's blowing through the condenser,
yep,
the fans are on, whether they're on or not, and
yep,
you cannot control your head pressure. I've seen the wind blow through these things at a minus 20 degree where it actually sucked all the liquid for the rack into the condenser, and the rack shut down on the differential. The vessel and the rack actually became the same pressure, and the rack shut down.
yep,
And once you do that, it's a tough scene to get that rack back up and running when all the pressure's replushed.
yep. Yeah,
but yeah, you got to put up. And we've had this conversation with our customers that they need to provide wind protection.
Baffles and stuff. Yep.
On our, just a note on our, go back.
Yep.
On our new Flex 2.0 racks, we've changed the design. You'll actually have doors on the back that open and close versus the panels you have to lift off, which can be a pain in the behind.
Oh yeah, yeah. And that's just design growth, right?
Yes. As we're making it better. We converted a mini flex from a VFD to a digital on the low temp to get more suction capacity, and we had to change the valve out because the valve is actually bigger for the digital head. But brazing tech, they could have been better.
Yeah, definitely brazing technique there.
Yeah. But it was nothing against the contractor. We were in a tight situation. We didn't realize until we actually tried to put the old line back on the new head that it was undersized. So we were in a time constraint.
Yep.
This is actually looking at one of our new mini flexes. Needless to say, it's tight in there.
It is tight. Oh man, it's tight.
It is.
This
tight.
Is what the end users
I really
want.
feel for the person that has to work on this.
Yeah,
because
this is what
go ahead.
This is what the end user want. They want very small. They want very light. They want very compact, because every space, even on the roof, is space like that costs money. So they're trying to compact everything. So
yep.
You guys designed a system for what the customer's asking, but that is tight. Like that accumulator right back there.
Yeah, that's the receiver.
Reservoir
from the opposite side. But boy, if you look in there, you can hardly see, but straight back at the top of that separator to the left is the gas bypass valve. Just on the other side of that pipe clamp. Yeah, you'll never see it. Trust me.
There's one right there. There's the flash gas bypass valve way back there.
No, that's actually the high pressure valve back there.
That's it right there?
Yep, that's the actual high pressure valve. That's
okay.
the CCMT4.
Oh, you're using the CCMT?
Okay. Yep. Yeah. And on the right, like I said, right behind the separator is the actual flash gas bypass valve.
Over there. Somewhere.
Yeah, she's tight.
Yeah, that's okay.
But that's an actual convenience store. That's on a quick trip. That was a job done with Emerson with an E3.
This one here?
Yep, that's got an E3 control on it.
Cool. Excellent. Okay, and then we got here, this is a Cree1, I think.
All right, so on our new Flex 2.0, they're using the Cree1 modules. They operate basically the exact same as the CC200, except that these are optical switches.
Optical. Okay.
So clean oil is a necessity.
Yeah, very, very important.
Yes. And they'll do the exact same. They cycle 5 times before they lock out. So maintenance, separator filters, Westermeyer. Temp-Right had probably twice the surface area as the Temp-Right or the Westermeyer, but the Westermeyer was really efficient. You have an upper and lower donut gasket you can see down there.
They get the bottom one there.
High gas slide comes in from the bottom of this filter and out the sides. So if this filter is just slightly dirty and you're going to transition into transcritical, subcritical operation, you can have a very massive mass flow differential there.
Mm-hmm.
And it doesn't take but 25 PSI differential to split that.
Yeah.
If you're with Westermeyer's, I recommend every 6 months doing a differential pressure test. And that would require I myself use a Dewar 0 to 5,000 PSI differential or digital pressure gauge. It reads in bar, reads in kilograms, it reads in kilopascals, it reads in PSI. You can check Danfoss controls reading in bar, you can check Emerson, Corel, and Danfoss reading in PSI. But you need to check the differential. You cannot be less than 0, because less than 0 means you've probably blown that thing apart.
Yep.
You got to have a differential. It's designed for 2. And anything greater than 12 PSI, you need to change it.
Yeah.
On startup, very important. The 2 to 7 days after startup and 100% operation, you're going to change that filter. And if you have suction, the inline suction filters, you're going to change them also.
Yeah.
They're going to also go back. The separator filter, if it's dirty and you look inside of it and it's not a manila white, and you're going to need to change it again in 2 weeks.
Yeah.
Sorry, in a week. And every week thereafter until that filter finally runs clean.
Yeah, because it still should not look black like this. It should look, you put it in for a week, you pull it out, it looks like it's brand new. It should look like it's still brand new.
Yeah, but yeah, it's very important. And this is the inside of a Westermeyer. They got a strong back in there. You just loosen. I recommend loosening those 3 nuts. They're hex nuts with stars on the bottom with a built-in washer. The Westermeyer recommends changing them. I say leave them in place, because if you drop that nut, you're going to go fishing for it. You have to get it back. Then you're going to turn that to the right, pull the separator filter out. Luckily, hopefully it comes out easy and the bottom gasket comes with it. Yeah.
Yep, exactly.
It should take more than 45 minutes to do this.
Okay, I get that question asked along. How long does it take? So this is in this scenario, there's only one oil separator. So this is, you got to pump down this whole rack. So you're isolating the rack, pumping it down, and then you're isolating the separator, because now you get the compressors, the whole rack's off. You isolate the compressors, you lock out the power so nothing turns back on. You change the alarms, set points for your working time. Then you remove the pressure from the separator. You do not open it without removing. It's no different than HFC systems when you're doing it. So you remove the pressure, so it's down to 0, and then you take this off. You're saying that process there, and then you pull out the filter and you change the filter, you change the gaskets. You're saying that should take around 45 minutes on this system.
45 minutes. The Westermeyer filter will come with a new gasket. If that gasket is not metallic, check it before you open up your separator. If that round gasket is not metallic, if it's an O-ring, stop what you're doing. Don't do anything to the system. Call the factory or call Westermeyer. They will get you a metal gasket out. All right. I'm habitual how I do things, because I like to be really safe when stuff has the potential of moving on you. Yep. I will take all the nuts off with the exception of 2. Yep. I will back those 2 out, and then I tap it or pop it up to make sure there's no pressure in there before I remove those last 2 nuts.
100%. Same as a head on a compressor, exactly the same way. You don't pop it off. So you're saying inside the Westermeyer ones, if you don't have a metal gasket, is that correct?
That's correct. You see that O-ring groove at the top?
Yep, right here.
Yep, that's the gasket in there. I think it's still in place on that. It needs to be removed, and a new gasket needs to go in.
Yep, 100%. You always got to change gaskets every time.
That's a compression gasket.
Yeah, perfect.
The retorque pattern, spec from Westermeyer is star pattern, 55 pounds torque.
I think it's the same as Temporite too. I think they're both the
I think
same.
so too.
Not it's
Right?
not torque. It's not what is it? Drill drill setting. It's
Yeah.
use a torque wrench, guys. Get a
I can
torque
tell you
wrench.
though, if it leaks to 55, add a little more torque to it.
Yeah.
My computer's down. I got to plug it in.
Yeah. Oh man, because there's so much going on here. So
Yeah.
this here looks like the outlet drop leg.
Oh, yeah, I had the contractor, he had some gum tape around it. So I took a thermal picture of it. I wish I had sent that to you, Trevor, where the gum was 90 degrees, the pipe was 72 degrees. So what do you think the temperature was? Probably closer to 90 degrees.
Yeah.
Because it was the valve, we were having issues with pressure,
Yeah.
and how the valve was operating. The valve was really wide open.
Yeah. Yeah. So that's why this sensor is so important. So important. I think we got two more pictures here. So one here, and we're talking about this one here.
All right. Yep. So this is the termination sensor on the Heatcraft evaporators. Okay, that sensor's square and it's on the end of the return tube. So how much contact do we have? About that much, right?
Yeah, just like a touch.
Turn it and put it on the side, so at least 2 points are in contact. And on Heatcraft, or any evaporator, go by the manufacturer specifications. On that one, it used to be the third return elbow down on the front. They have since changed that because of we were getting a little bit of frost buildup on the bottom of the evaporator. They wanted to go midway midway down on the front of the evaporator.
Yeah. So this is in the manufacturer's information. So what you want to do is this is a little bit better, but you want to go straight across with them. Yeah,
you want to get as much contact as possible, and that gum insulation around there is really good.
Yeah, for sure. It's perfect. I think that was the last one.
Okay, wow. So while we were on that, our pulse valves, what we do with our pulse valves is, in case anybody doesn't understand how they operate, we're going to get a percentage of valve control from the controller. There's an algorithm built in there based on superheat temp. We have a 6-second period. So that means the valve, if it's open for 100%, then the valve's open. It's just open like a solenoid until we start getting a call for 90%. 6 seconds at 90%, just a real weird guess, is probably half a second off. If it's 50%, the valve's open for 3 seconds, closed for 3 seconds. Please don't mess with that cycle.
Very good. Yeah. You shouldn't in any of these controllers. And that's 100% because it's going to change up how it works, run into issues. And when you run into case issues, then you run into flash tank issues. You run into a high pressure valve and flash gas bypass valve issues because all this system works together. All the whole system works together. So very, very important.
Superheat on our racks. In the old days, superheat was simple. You looked at the cases. If the cases are flooding back, then you're going to have low superheat. But on a CO2 system, you'd be very cognizant of your gas bypass valve because we're creating a pressure drop. Even though it is a 100 pound or less pressure drop, it's still a pressure drop. So when that valve's just opening up a little bit, we can actually create liquid droplets.
Yeah.
And if you've got low superheat on your medium temp rack, after you verify it's not from your medium temp, low temp circuit, start looking at your big gas bypass valve. That could be your other culprit.
Unbelievable, man. This is a whole schooling session. This is amazing, Paul. I really appreciate you taking the time to teach us all of this, like from startup to commissioning, some maintenance stuff. Like this is hands down. I've learned a ton of stuff from you today. Last question before I let you go here, because I could talk to you another 3 hours, and I know you could.
We'll have to do another one of these on troubleshooting.
Yeah, exactly. What would be like 1 or 2 tips for technicians who's starting to get into startup and commissioning that, man, start to do this stuff and it's going to make you better as a startup commissioning tech? First
and foremost, find a good mentor. Really, find somebody that's willing to teach you. Number 2 is just learn the parts and the pieces of your equipment. You got to know how everything works if you're going to diagnose. You can't just walk up to rack, and I've looked at one of these twice. The biggest thing with the startups I've done have always been with the startup guys. And then I have a class and I teach all the startup guys how the rack runs, what to look for in maintenance. But then a week later, the next guy on the rack is the poor soul that's on call, and he's never even seen a CO2 rack. CO2 is here, guys, and it's not going away. It might cost a little bit more out the gate, but when you start looking at maintenance cost, it's no more than an HFC rack, and the gas is way cheaper. And that's going to affect the end user, bottom line. So if you're going to spend a couple dollars for CO2 versus $50 to $150 for refrigerant, it's not a big brainer there on what you really need to look at.
Yeah.
These racks, you do the maintenance on them, they will just chug right along and be really efficient and work for you.
I love it. Paul, I want to thank you. Paul, I want to thank you so much for taking the time to hang out with us. Yes, we'll definitely do a troubleshooting one because I'm interested in learning more. This is why I do it each week. And this is why you guys are all here listening. There's people still here hanging out. I want to thank you, Paul, for taking the time, and head to Hillphoenix's website. Go check out all their different manuals on their CO2 equipment. They got a ton of it there. I'm going to check out the bulletins. It's going to be in the description. Once again, share this on your different social media platforms, Instagram, LinkedIn, Facebook. The knowledge is here. Just share it so other people can know. And anything that you learned here today, share it with someone else. This is how you get better. This is why Paul is so good, because he continues to share with people and he learns from what he's sharing and he's growing. Paul, I want to thank you so much for taking the time today to hang out with us at the Refrigeration Mentor podcast. And I can't wait to chat with you again on another one.
Appreciate the invite, Trevor. Sorry it took so long, but it's been a busy couple of years.
We'll do this again.
One last thing I want to throw out there on our racks, we have a QR code up on the rack. That will now show you the startup manual. Going forward in the future, we're going to add like parts lists, warranty forms, how-to videos from Reverend Rusty, stuff like that. We're gonna put more information up there, make it easier for contractors.
Love it. That sounds so awesome. Paul, once again, thank you so much. Thanks everyone. We'll see you at the next see you Monday.
Thank you guys.